that I've said I'm using is called Xcode, and this is where I'll be writing my C programs as we look into a brief introduction to the C programming language. And I'll select command line tool, and what will I name my project? Introduction to Programming. So it's an introduction to programming, and my language is C. And yeah, I'll finish my setup. Where do I save it? I can just save it anywhere. And yeah, this is my program, and I'll open my main file. So when you're coding in C, ensure that you will be working on the main.c file, this main file, because I have seen most of us on our computers, we tend to create and go to file and then new and then file, and then you create another file that is named untitled. And when you work on an untitled file, the C won't be configured well. So it's best you just work on the main file that C provides you with, the hello world, the one that contains hello world. So what you can do is you can be deleting all this stuff and starting your own code, or just add your code here. So if you want to add your code, just add it here. Yeah, that is what I'm saying. So ensure you work on the main file, especially when you're using your computers. Those that will be using the mobile phones, this is what you'll already find when you create your app. So this is the typical hello world program, and when I run this program, it will output hello world, and you can see that the build is succeeded. And when I output, you can see that the output is hello world. And I don't know if I can maybe increase the font so that you can be able to see well. So let me go to the settings and increase the, what do we call it, the terminal console, yeah, the console font, and just increase the font to maybe 24. Yeah, 24. I'm pretty sure you will be able to see that. So that when the output is, yes, now this is good. So you can see that the output is hello world. And if I wanted to change, I just come here to the printf function and change. So we'll explain what all these are. And just know that if I wanted to change and say, hi guys, my name is Ken, but I'm not Ken. I'm Eric. So if I wanted to output that and I run my program, you can see, hi, my name's Ken, I'm Eric. So let me just change it back to hello world. So that is the printf function, and what it's used to do is to display output to the console. So now look at this program. What we'll do is we will write this program now from scratch, and you can just discard all this. The main function, you don't have to have all these things that oh, okay.
You are not sharing the screen.
Okay. So guys, can you see my screen? Yeah, I think everyone can see my screen. If you can't see my screen, just log out and then log back in. I hope you are seeing the code. Can you see the code? Can you see the code that I am in? As I was typing the code, yeah, I think most of us can see. Yeah. So this is the code that I was talking about. But if maybe for some it hadn't refreshed, I can stop sharing and then start sharing my entire screen again, and share my entire screen. So you can see my screen now, everyone. Right? I hope you can see my screen. Give me some reactions. If you can see my screen, just react so that I can know that we are all together. Yeah, so I think we are all good, and I'll get rid of the infinity mirror. And now as I was saying, um, this is that's the Coding C app. You will download it on your mobile phones, and what I'll do is I'll just delete the entire code so that you can start from the beginning. And what I want us to start with is understanding what a programming language is. So let me just have them as comments. So let's start by defining maybe what is a programming language. And so C is a programming language. And now what is a programming language? So if you were to look at it into just an overview definition, this is how we can talk to a computer. So just think of it as any other. So you can say think of it as any other language, e.g. maybe English, maybe Espanol, Spain, the Spain fans who won yesterday. Also we can have French. So just think of it as as any other language, and in these any other languages, in any language we have rules on how to communicate. Like how I am communicating to you, I'm just having words, I'm putting words together, and I'm doing that in English, and English has its rules in such that we normally have rules such as SVO, which is the subject, and then verb, and then object. We have such rules, okay, when maybe creating our sentences. And now in a programming language for a computer, we also have rules. So rules for a computer programming language, these are what we call the syntax rules. And in C we have different syntax rules, and some of these syntax rules, some state that after every statement you have to end end with a semicolon. So these are some of there are so many syntax rules that are maybe present in the C programming language. And also we have a rule that you should never have spaces in your variables, or you should never start your variable name with a number. So these are the different types of rules that we might that it's not that we might have, that we have, because you can't go against these rules. And also another rule is that C is a case sensitive language. So if you write something like printf, which is used to print something to the user, C states that if you write this P, like capital P, your program won't work because you have broken the syntax rule that C has. And C says that in writing your function, if your function is named as printf with a small p, you can't change that into printf with capital P. So these are the different syntax rule. And now, following all these, the C grammar syntax rules for the C grammar. And now this C programming grammar is now what you put together to talk to a computer. Is what you put together to now talk to a computer, or write programs that can actually talk to a computer. And in this case today we will be writing a program that will display some output to the user. And we have different programming languages. It doesn't have to be just C. Different programming languages. So if you don't want to be coding in C, you can code in other different programming languages. So another one is a language like C++. We have a language like Java. We have a language like Python. We have so many languages. They are in the hundreds, but some of these are the most common. A language like JavaScript, we have C#. So now all these languages, they have their different use cases. A language like C, it's used in the low level stuff. So just think of it as maybe robotics, automotive, in these very low level stuff. And actually C is quite a robust programming language, because Windows OS was written, ama is written, it's not was, is written in C. So you can imagine the robustness of C, having to write an entire operating system. So the Windows that you use, just know that it was written in C. A language like C++ is widely used in making games. So these are the very fast programming languages. So C is actually a very fast programming language. That's why you see it can make up an entire operating system. C++ is also a very fast programming language when it comes to execution. And you can see it's just not used in making games, it's used in making so many other things. But yeah, most games actually, or most games and game engines. So a game engine like one I use, it's normally called Unity engine. It was written deep down, it's written in C++, and it uses C# in its programming. A language like Java is used in backend systems. So an example is what we have in Java called Java Spring Boot. We also have Java Enterprise Edition. So Java is quite used in enterprises. That's why it has even an enterprise edition. And also, don't forget that it's also used in Android. Used in Android. So quite a number of these Android apps that you're using, you'll find that they were written in Java and Python, mostly used in AI and data science. This is because there are so many libraries for AI that that are used in um, that are used in AI and data science. So all these things, all these fuss that it's not a fuss, it's just actually something that is changing the world about AI. You'll tend to find it's written with Python. Something like JavaScript, mostly used on the web. So JavaScript, if you're using a website, most likely you'll tend to find that it's actually running some JavaScript, and you can actually test that out. If I can come to this Coding C website, if you want to maybe see some code for this, you can right click and then say view page source or inspect. So let me view page source and see. So this is some HTML and some JavaScript and everything. So this is some of the code that entail. Some websites actually show it quite well. So let me see the code blocks website, then view page source. You can see this is some of the HTML code, and you'll also find some JavaScript classes in here that are maybe referenced. So JavaScript, you'll normally find it on the web with so you can see, like, here is a script. Its source is this one. It's called ads by google.js. This is where JavaScript is mostly used. So this is just to show you that there is no best programming language. If someone told you just learn C, it's the best, just learn Java, it's the best, or learn Python, it's the best programming language in the world, there's nothing like that. What we have is best programming languages to do a certain thing. So like if you wanted to do AI, you wouldn't pick up a language like Java. Yes, Java can do some AI if it wanted to, but Python is best in doing that. If you wanted to build an Android application, you wouldn't pick Python because to build an Android app, Java is best known for that, or another language that is called Kotlin or Kotlin. So Java or Kotlin is normally used in making Android applications. And if you wanted to build on the web, you can choose a language like C, and you want to be a web developer, choose a language like JavaScript. And also C# is also used in backend systems, and also used in making games, something like Unity or Godot engines. So these are the different, this is just a tip of the iceberg when we come to programming languages. We have languages like Go, we have languages like Rust, we have so many languages. And each of them has its strengths and weaknesses in different stacks. So now today what I wanted us to now cover is now a brief introduction to C programming, because actually people prefer to start with C as their first programming language because it will teach you quite a lot, and also since it's a strict language, it will show you, it will build a strong foundation when it comes to knowing your types or knowing how to manage your memory if you get deeper into C, or just since it's a very syntactically typed language, you won't have a hard time transitioning to any other language. So now I want us to start with a typical C program. The first program is the Hello World program. And we have the Hello World program. And you have definitely learned this. And to start with a C program, what you need to do is what you need to do is start with the first statement, or what the first statement in a C program states is you start with the hash include, and then you say angle bracket, and then stdio.h, and then you close. And what is this hashtag include stdio.h? This is what you call a preprocessor directive. And what does it do? This preprocessor directive is used to import the necessary libraries to our C program. So in this case, the library that that we are using or importing is the what do we call it? The std is the stdio dot header library. And what does this library provide? The stdio.h library is normally referred to as the standard input output library. And this standard input output library, it will provide the different functions that will be used for input and output in our program. So by writing this hash include stdio.h, we can now use the different output functions, e.g. printf, or the different input functions such as scanf. So these are the different. To give output, we use printf, and to do the input, so if you want to get the input from the user, you use scanf. And that is the use of the hash include stdio.h. And next, after writing the stdio.h, and as you can see, what I'm using, these double backslashes, actually this can be a question that you can be asked. These forward backslashes, these are what we call comments. And the use of a comment is used to further explain the code, or it can be used to disable parts of the code. So if I wanted to, as you can see here, I am explaining what the hash include does, and what I'm doing to explain is I'm starting every sentence with double forward slashes, and double forward slashes, they are what we call comments, and we have different types of comments. We have so let me just say types of comments. So we have the inline comments, and we have the multi-line comments. So a multi-line comment is a comment that you don't have to be writing these double forward slashes every time. If you wanted to comment like a whole paragraph, like what I have done here, you can see that here I am not using those backslashes. I am using what you call a multi-line comment, and a multi-line comment starts with a forward slash, and then you say star, and wherever you want it to end you say star and then forward slash. So this means that whatever you write inside this, it will be a comment, and this is now what we call a multi-line comment, or these are commented. So that is how I am able to write so many things in here. And for an inline comment, they are for a single line. These are for a single line. And multi-line comments, they are for multiple lines. That is now the difference. So if you're wondering why I was using these double forward slashes, that is the reason why, because they are called comments, and they are used to either give further explanation to your code, or just do what, or just comment. So if I wanted to disable this hash include, I can just turn it into a comment and just do like that, and it will disable that piece of code. And we have explained what a preprocessor directive is, and say that it's used to import the necessary libraries to our C program. So now the next part, and the reason why you can see that there are so many comments, it's because the comments will be ignored. So in our program, the only thing that we have written is just this hash include. This is what the computer identifies, because the computer, when running our program, it will ignore, it just ignores, it just blue ticks all these comments. It doesn't care. It will ignore all of them, and the statement that matters is only this, the hash include stdio.h. And after that, we now write your main function. And now to write our main function, we say int main, and do like that. So this is our main function. And you can ask yourself, what is the essence of the main function? The essence of the main function is to act as an entry point of our program. That is the essence or use of the main function is to act as an entry point of our program. When you run your program, the computer has to know where to start. It doesn't just start from anywhere. Like in the case of JavaScript or HTML, it will start from up here. It starts from the top, and then it goes interpreting everything to interpreting everything. And in our case, what our program will look for is the main function first. Even if you had so many things written up here, they won't matter. Apart from these, maybe hash include, these preprocessor directives, they will be executed. But where your logic will start is normally from the main function. And this is what will happen if I would run my program. If I would run my int main, and then let me just write it that return 0. If I would run my program, there won't be much output, or there won't be any output. So you can see program ended. So this is just to say that the program has ended and there is no output, since my main method, it doesn't have what, it doesn't have anything that we are doing here. So if you wanted to maybe display something, you should write it now inside your main function. And if I was, let's say, if I wanted to, we said that comments can be used to disable some part of the code. So if I wanted to disable these int main, I can do like this. I can use inline comments to disable all this code. As you can see, it has grayed out the code. But if I wanted to do that in a much faster way, I can use a multi-line comment. I say backslash star, and then where I want it to end, I say star forward slash, not backslash. And you can see it has grayed out my code. So I wanted to gray out the code and try to run my program and see whether it will run. No, it's because the computer has not found something that is called main. If you look up here where my cursor is, you can see that there is an undefined symbol called main. So that means that when the program was about to run, it did not find the main function. And as we said, the main function is where our program starts executing. So if it doesn't find that, your program won't run. And that's why I have commented out so that you can see. And if I return my main function, the program can now run. As you can see, it's running properly. So that is the use of the main function. And now, to make our main function do something, we said we can now use these standard input and output, and is used in this case. The library that we are using is the stdio.h, and it has an output function called printf. And now this printf is what we are going to use to output something to our console, because our program is not outputting anything. So now if I want to output, I just write printf, and now whatever I want to output, and as you can see, as I write now, this is what we call a statement. Printf is a statement in C. And after writing your statement, you have to end with a semicolon. And also return 0 is also a statement, and that's why after writing 0, I have to also end with a semicolon. And to print out, so printf, this is a function that is found, it's found in the stdio.h library. It is used to display, let's just say display stuff to the user. It's used to display stuff. So whatever you put inside the printf function, it will be displayed to the user. And to display something, you have to use the double quotes. So now whatever you put inside here is what will now be displayed to the user. So you just say hello world, and writing just hello world, that means that you want to display the word hello world to the user. And when I run my program, you can see the build is succeeded, and you can see it's displaying hello world, and then it's displaying program ended with exit code 0. This exit code 0 is what was there even if we don't have anything to output. So if I comment out the hello world, you can see by default it says program ended with exit code 0. So now you might ask, why is it writing this? So this is normally used by the operating system to say whether your program ended with an error or it ended without an error. So if a program ends with 0, it means that your program did not have an error. So if you wanted to maybe capture an error, but that will be when you are writing advanced C programs where you maybe try and catch some errors in your program. If you wanted to catch an error, you would return something like 10 or 50 or 13. So if I say return 13, you'll see that this statement down here will say program ended with exit code 13. So whatever you put here is what will be displayed here. So if I run my program, you can see that it's saying program ended with exit code 13. If I say 23, so the same thing, program ended with exit code 23. And I have had maybe a message, so let me see. I hope you can still see my screen, but these were chats from some minutes ago. I hope you can still see my screen. You can just react. If you can still see my screen, just react. Awesome, I think we are... Keegan, why can't you see my screen? Just try and join the call again. So I don't know why some students can't see my screen. And I am sharing my entire screen. If you have some difficulties, just try logging out and then logging back into the call again. Yeah, so let me just get back to the code. And as we were saying, if this return down here, it's what will define what the program ended with the exit code. So just think of this as the exit code. Return 0 represents the exit code of the program, and a 0 means that the program executed successfully without any errors. So if you return 0, it means your program did not find any errors. So now what I want us to do is now return the printf. So you can see here we said printf hello world, and there's a problem that we can see here, that everything is joined. We want to maybe have a space between hello world and program, or this program should be displayed on the next line. And to do that, we will use something we call escape characters. We have something we call escape characters. Let me just use a multi-line comment. So I say escape characters. What are these escape characters? These escape characters, they are used to maybe define what the program execution should do. So if you want to go to the next line, you can use a next line escape character. And for the next line escape character, we normally represent it as \n. So if you wanted to go to the next line, after you display your output hello world, you end with \n. And what that will do, it will now display the hello world, and then display, go to the next line. So think of these as go to the next line. Go to the next line. So just think of it as that. Go to the next line. So this is next line, escape character. We have others, and now if I run my program, after displaying hello world, it will go to the next line. So you can see it has gone to the next line. And if I also wanted it to have a space, I would just add another \n. And as you will see, it will increase in size. So you can see there's some space down here. And you can also use it between sentences. If I wanted to say hello and then go to the next line and then display world, I can do exactly that. So in between there, I just add the next line escape character, and you will see that when I output, it will say hello, go to the next line, and then say world. And if I wanted it to skip 2 lines, it's just the same thing. Hello goes to the next line, and it also goes to the next line, and then outputs world. Yeah, so these are some of the escape characters. So to just give you another one that maybe you might use is the number 2. We have the next line. Number 2, we have the tab escape character. So tab, these are it's represented as \t, T for tab. And T for tab, what it does, it gives a tab space to your output. Now if I pressed tab, it will, you can see that my cursor moves on forward. So that is how I am pressing tab. If you didn't want to do that on your program, like manually, you can just use \t. So let's say hello world was joined. Hello world is joined. You can see that hello world here is joined. So now what I can do is I can come here and provide the different spaces. So tab is normally 4 spaces. So let us see, 1, 2, 3, 4. So tab is something like this. Tab is it's normally a space like that. So I have added the space manually. So you can see there's that space. But now the problem will come. If you are writing a program like this, and then you have so many words to display. So maybe after world, you just have to display. You go to this is programming. You can see that you will use so many spaces, and that will be a problem. So you can see it's even not readable well. Now what you can do is now use the escape character, tab escape character. So you can just come here and say hello world, and then let me just run it so that you can see the difference. These words are joined. But now if I use the escape character for \t, it will provide a tab between these 2 words. And if I run my program, you can see it has provided the hello world and it's spaced out. So that is what we have. We have many different escape characters. Tab, there's an alert. If you wanted to maybe your program to produce a sound, you can say escape character. For producing a sound, you say \a for alert, produces an alert sound. So let's see whether it will work. So printf, and then say alert sound, and then say \a, and then go to the next line \n. I don't know whether you can hear the sound, but it really works well on the Android. If you use your Android programming IDE, this app, if you use this app and say \a, it actually produces a sound that you can hear quite well. So let me hear where I've never tried this, but let me hear. I think it could have produced, but you wouldn't hear because maybe the speakers aren't sharing. But it's used to produce an alert. So this is like a brief now overview on our C program. So up to there, maybe if anyone has a question, let's see if there are questions. So you can maybe raise your hand or just type out on the comment section whether you have a question. And I think we are all good. So I think as the last thing to look into is how we can now create how we can create now a much more useful application, because now what we are doing is just displaying stuff. It's just displaying. There's nothing our program is doing. It's just displaying. So if we wanted a program that can maybe be used to uh, calculate math problems. If we wanted to do such a program, we can actually do that, because something like our calculators, let me see whether we can see the programming language that was used. Language that was used to program Casio calculator. So let's see whether it was Casio Basic. So it had its programming language for, but you can see there are some actually some calculators that use the C programming language. So most of these programs, they actually use the C programming language, because Windows itself, as you said, it was made in C programming. So we can create our own maybe calculators and everything. And what I will do now is, our program is now just displaying hello world and then printing an alert sound, of which that is not quite useful. If we now wanted to create a more useful application, we have to now give it some other functionality. And what I'll do, I'll just discard this hello world and give the calculator a title. Give the a title. So we say printf, and then math calculator, and math calculator here. We can just name it as that. And don't forget that after everything you print, be going to the next line where necessary though. Now what we are printing out is math calculator, and we can start with the first number and the second number. So in order to store our numbers, so what a math calculator does, you maybe provide it with the first number, and then you provide it with the second number, and then your calculator should do something like add the two numbers, or multiply them, or divide the two numbers, or just subtract them. So what you need to have is, you need to have the variables for two numbers, and that is exactly what we will do. And this is where we learn something about data types. And data types, we have, let me use a multi-line comment. So we have the data types. Then you say data types. And the data types, we have four major basic data types. Basic data types. And I should write these as maybe a header here. Basic data types, because we have basic data types and derived data types. So for the basic data types, we have majorly four of them in C. And which ones are these? We normally have, in this case, we will be needing to create a calculator, and a calculator involves numbers. And in this case, we have a data type like an int. You have learnt about an int. So an int is used to store whole numbers without a decimal place, without a decimal, or without a decimal, yeah. So just think of it, just think of an int. It's used to store whole numbers that don't have a decimal place. And an example of an int is a number like 1, a number like 100, a number like 9999999. And don't forget, it doesn't have to be a positive number. You can also have a number like -1,3,000,000 or -10. So an int can store both positive and negative numbers. So that is an int, but it has its limit. The maximum int value is something to do with 2,400,000,000. Let me just get it. Maximum int number in C. You can see it's 214. 2,214,000,000. So that is the maximum int variable. So that is the maximum number that an int can store. So minimum, as you can see, the minimum now is the negative of it. So it can store numbers from this to the negative of it. So plus or minus. So this is the range of an int. And the other data type is, now, let's say you wanted to use a number that now has, that can provide the decimal places. So the first one is a float, used to store numbers that can include a decimal place value. So that is a float. And another data type is the decimal. And a decimal too can be used to store numbers that can include a decimal place value. But as you can see, they have the both definitions, like both of them have the same definition. So you tend to ask yourself, why did they not just settle with maybe either of them? It's because even if they have the same definition, they are actually different. And one of the differences is that a float is smaller in memory size than a double. So a float is actually smaller in memory size than a double. So this means that a float won't be able to store a very large number as compared to a double, and this is not decimal, it's double. Sorry about that. Than a double, and a uh, double is larger than a float in memory capacity. So a double can now store a number that is larger than a float. And another difference is that for a float, it normally has float float number has single decimal precision. It has a single decimal precision. So this means that it doesn't offer as much decimal place values as the double. So it offers maybe up to 7 decimal places. And now a double, it has what we call now double precision, and that is why it's called a double. Double number has double decimal precision. So this means that it offers more decimal place values as compared to a float. And in this case, up to maybe 15 decimal places. Let us see double and float decimal places in C. So you can see that a float, it has 7 decimal digits precision, and a double, it has 15 decimal digits precision. So if you are asked, and this is what you said in memory, for a float it has 4 bytes, and for a double it has 8 bytes. You can see that a double is larger in memory and also in the decimal places. So these are the differences that we are talking about. It's an integer but with decimals. You can see it's exactly the same thing that we were talking about here. And yeah, so these are the different data types. And the last one is a data type it now doesn't involve the number. So this is the first one, this is number 1, this is number 2, this is number 3, and this is number 4. So let's go to number 4. And number 4, we have a character. A character is a char is used to store a single character. And an example of this is examples. We have a character like A, or a character like U, or a character like I or P or J. So these are the different types of characters, but these are not yet. If you are asked in an exam and you just write these as your characters, you would have failed, because for you to represent a character, you have to use a single quotes. You have to enclose it in single quotes. So these are now the character representations. You have to use a single quote, and mark my words, single quote, single quote. And also another thing, for characters don't have only to be the alphabet characters. It doesn't have to be, don't have only to be the alphabet characters. We can have characters like number 4 can be a character. If you write number 4 and enclose it in 2 different single quotes, that's a character. If you write number 9 and then close it on two single quotes, that's also a character. And also, they don't have to be just numbers too. Also, it can be symbols. If you say and, it can also be a character. If you say percent and then you enclose it between double quotes, it can also be a character. So think of it as the entire keys on your keyboard can all be represented as characters. The same way that I am typing these messages, I am clicking each character one by one, one by one, one by one. So all those are represented as chars. And now that is what defines a character. So now to create our calculator, we will need to know the data type that we will use. And in this case, since we have something to do with decimal, because let's say our first number to be 17, and then second number to be 2. If you do the math division of 17 and 2, you'll tend to find that the answer is 8.5. Yeah, the answer will be 8.5. So 8.5 is a decimal. Now, if you use a data type like int, that won't take care of the 0.5 decimal place. Now we have to settle with another data type that will provide a decimal. We just have to choose whether it's a float or whether it's a double. In the case of memory, you can see that double is larger than float in memory, and you can see that we are not using numbers that are really big, so we don't need to use a double. What you can do, you can just use a simple float, and we can say now we can have our define our first number, or define our first number variable. And what you'll say, you say float first number. And now we say that you should never have spaces in naming your variables. If you want to have a space, just use an underscore to join the two words. If you don't want to use an underscore, just join the two words manually. You should never leave a space, because if you do like that, if you say that the first number is 17, your code will run into an error. You can see that it's already telling me that there is an error on this line. What I need to do is either introduce an underscore or just join these two words. And I have said that float first number is equals to 17. What you can represent this as, you can say first float number, and then a second step is called assign the variable. And for assigning, you say first number is equals to 17. That is what we have done. We have defined and then assigned. But you can do all this on the same line. So for the second number, let me do on the same line. So float second number is equals to 2. You can see that the second number, I have done everything on the same line. I have done declaration, define, or declare. It's called declaring our first number. So I have done declaring and assigning on the same line using the equals sign. And I've heard a message. Nope, it's not. And yeah, so if you have a question as we are going on, though we are just completing, you can just do what, you can just post it on the chat. And this is what we have done. We've said that the first number is equals to 17 and the second number is equals to the number 2. What we now want to do is to do perform different math operations to these two numbers. And how do we perform the different math operations? We have add, we have subtract, we have multiply, and also we have divide. To do that, we will now need different other variables that will store this calculation, because after every calculation we have to store the result somewhere. After every calculation we store the result somewhere, and in this case we'll need for adding, we'll need for subtracting, because all of these will yield different they will yield different answers. That's why we need different variables. So for the first one is float add, and then we say it's not float, it's float. Float add, float subtract, then float multiply, and then float divide. And if you know Ed Sheeran, you can, he has an album of all these add, subtract, multiply, divide. Yeah, you can look that up if you are a fan of Ed Sheeran, but I'm pretty sure you already know. So we have all of these: add, subtract, multiply, and divide. Now what we need to do is now do all these calculations, and we say for the first one we say add is equals to now here is perform perform the math arithmetic for each of the declared variables up here, and then you say add is equals to the first number. We want to add the first number 17 and then plus the second number 2. So you just say add is equals to first number 17 and then plus second number. And what that will do, it will take the first number, which is defined here as 17. So just think of this value, it will be 17. And then the second number will be just 2. And think of them as that way. The calculation will be 17 plus 2. And whatever the result will yield on this right hand side, it will be equated to whatever is on the left hand side. That is what the equals sign does. The equals sign takes whatever is on the right hand side and assigns it or makes it to whatever is on the left hand side. So the value that will be got from this calculation will be stored in the add variable. So this 17 shouldn't be there, and also these 2 shouldn't be there. And the name that you use up here, if you say that this is first number, this name, you should not change it. You should not change even a single character. So if you were to introduce an underscore here, you'll see that the computer will start shouting down here that it doesn't know what first number is, because you have changed, you have actually changed the first number here to be with an underscore. So it doesn't know. You have to use the exact same name that you defined up here. If you define your first number with an underscore, you can see that the computer is shouting to you, it's undeclared. It's undeclared because you have introduced an underscore. What I'm trying to say is that whatever you start with, whatever you call your variable name, it should be the exact same thing throughout your program. You shouldn't add anything. And now what we need to do is we have said that the addition is equals to the first number plus the second number. For an output, we can maybe try to output that add thing. Then we can say printf, printf, and then say addition is equals to, and now here is where we introduce another concept. Addition is equals to %f, and then you say add. And let me just run so that you can first see the output, and I will actually add a line there and another one there so that you can see the output. What you expect is 17 plus 2, which is equals to 19. So it should say addition is equals to 919. And that is our program for the first bit. And as you can see, it's saying addition is equals to 19. But here there's a new concept that you have seen. And the new concept is this %f. What this %f means is something we call format specifiers. Let me just explain something little. So format specifiers, and they are mostly associated with displaying variables to the user or output. And what this means is each and every data type has its own format specifier. Each and every data type has its own format specifier. The same way that we said we have different data types, each of these has its own format specifier, so that if you want to display it, you will use a different format specifier. So let us start with an int. The format specifier for an int, the format specifier is normally %d. For an int, it's normally %d. For a float, it's normally %f. For a double, we said float and double, they are more like the same thing, %f again. And for a character is normally %c. This means that if you are displaying an int here, if your data type here was like int first, you would have said %d and then here first. This is what is used to display an integer. For an integer is %d, but in this case we are using a float. So the float, first number, second number, and also for the add now, which we are displaying, to the output we are displaying the add. So for the add, we are using a float. So add is a float. And what have we said about a float? A float, you normally use %f. %f. And so here is what we have to write, %f. And we normally said, we actually defined what these \n are for, and they are to go to the next line. And now to display this %f, you will have to provide whatever you want to display out here. So you just write your sentence and then you say comma, first number, and that is it. And let me increase my window just a bit so that it can so now this is what increases the first, it not increases, it just displays the first number. And another thing is that you have seen it's displaying with so many decimal places. You can see it has Answer is 17.00000. How many decimal places are these? 1, 2, okay, 1, 2, 3, 4, 5, 6. So it's displaying with 6 decimal places. And what you can do is you can actually say the number of decimal places you want. And to specify the decimal places, you can say 0.2. If you wanted to display just 2 decimal places, you can just say 0.2 decimal places, 0.3 decimal places, 0.4 decimal places, 0.1 decimal place. So let's see 0.2 decimal places. As you can see, it's displaying with now just 2 decimal places. That is how you can use this %f and how you can limit on the decimal places that it outputs. And the next thing we are going to do is now to do the subtraction. And it's just the same thing. You say subtract is equals to first number minus second number. And after doing that, you just display printf subtraction is equals to %f. I don't have to maybe format the decimal, %f and then \n. I am skipping 2 lines and then comma, then say subtract. And what I can do is now run feast. I have said feast number. As you can see, if I just misspell, the program won't run. That is why it wasn't running, and it was telling me that I have an error on line 101. Yeah, so build is succeeded, and as you can see, the addition is 17.00, subtraction is 15.00. If I want to format the subtraction decimal point to be maybe 1, I just say 0.1. And it will fix that for me perfectly. Subtraction is 15.0. The second last one is multiply, and multiply is equals to first number times second number. Simple as that. And for multiplication, notice that we use the star. And to do that, we have to display printf and then say multiplication is equals to %f. How many decimal places do I want? Maybe I want 3 decimal places. So I say 0.3f and then \n, and then now provide the multiply. The exact same name that is named right over here is what I will display right here. Multiply. And for the last one is divide. Divide is equals to first number, and divide you use the / single one second number. Simple as that. And then you display the output printf and then say division is equals to %. This one has a decimal place, so I can say 0.2f and then divide. And that is it for our calculator. If I run this program, you can see it is saying addition is 17, subtraction is 15, multiplication is 34.000 because I have specified here to be 3 decimal places, and division is 8.50 because I have said it's 2 decimal places. And as you can see, we have the problem where this program ended with exit code 0 is just finessing its way into our display. It's because I haven't added the \n for going to the next line on our last sentence, and that is it. It should fix everything. And as you can see, math calculator, addition is 17, subtraction is 15, multiplication is 34, division is 8.5. Yeah, so that is it. I know we have learned quite a lot. I think I can provide this script to all of you. I'll just copy everything and yeah, just share it with you if you want to look at what we have done. And also the recording will be available. I think I can upload it to my YouTube so that you can see and just follow along for maybe anyone who might not have attended the class. So now maybe if we have a question, if not, we can end it at that. Can you use more than one data type in the same program? Yeah, this is a very good question. And yeah, the same way I said, you can have the same way you saw me try to do int first. So you can see that we have used floats. And the reason why we used floats is because we saw that our numbers can yield to, our operations can yield to a decimal point. And that is why we used floats. So let me just show you why we used floats. If I convert them to ints, because I can actually do that. I can convert everything to an int. Okay, I can convert everything into an int. Come on, an int and also an int and also an int and also an int. So let me just show you the problem with doing that. But recall that we said to display an int, we use %d. Okay, so you also have to change here to be %d, %d, %d. And now see the problem with an int. Notice just everything will be okay, but notice the division. Look at the division is 8f. I think it's because I haven't deleted the word f. Yeah, it's df. So just let me just run it again. Uh, I haven't deleted f in these things. So it's treating f as a letter. Yeah, so you can see this addition is 17, which is correct. Subtraction is 15, correct. Multiplication is 34, correct. But now look at division. It's saying that division is 8. Is the division between 17 and 2 8? That is wrong. And the reason why is because an int cannot display a decimal point number. So that is the reason why we used floats, because for a float we would have been able to see that the actual division is 8.5. But what you are saying is correct. You can use multiple data types on the same program. So you can say even here char grade. If you wanted to calculate a grade, as we continue just programming or just writing much more complex programs, you'll tend to find that we'll be using all data types. If you want to create a calculator for what? For determining your grade, you'll be using characters, you'll be using doubles, you'll be using floats, you'll be using ints to calculate your marks, to maybe store your marks. And yeah, you can use different data types on the same program. So let me just undo so that we can return to where we started. Yeah, so that was a good question. Any other question? Any other question? If you don't have a question, I will now make these available because I was recording. And yeah, I will also share the script with you guys so that you can see maybe what we have looked into. And yeah, just know if you want to specify the decimal place, instead of just saying %f, you can specify the number of decimal places by saying 0.1f to 1 decimal place, 0.2f to 2 decimal, 3f to 3. And yes, you can use multiple data types in your program. Yeah, so that is it for the lesson today. We will meet physically next time so that we can pick it up from there and as we explore more on C programming. Yeah, so thank you everyone.